Okay, we're now recording. Did everyone get the assignments from yesterday? Or we passed them out Sunday, not from yesterday,
Yeah.
we passed them out Sunday.
Yes. I
Okay,
think
were they
we
clear?
got, yes. Test review and
Right.
test this week.
Yeah, I've mailed out the test review. I did it early this morning for 8 o'clock.
I have a question about how we'll take the test.
Okay,
Is it going to be just like the quizzes, or will it be different?
just like the quizzes.
Okay. All right. Thank you.
Yep, I'm trying to keep the same format to keep the confusion down. Only difference is the test will cover all of chapter 5,
Okay.
whereas quizzes only cover material for that week.
Yes, sir.
I think I would prefer, doing like showing work. So at least I got some PowerPoint instead like the quiz. If we got wrong, we got all wrong.
Yeah, I understand. And that's why I'm not exactly a fan of online. You got to understand, I understand, you think you're just one person, and you are. But if I went, yes, the standard format, I've done it for 32 years, is that we're in the classroom, I give you out the test, you write your answers down, I give you partial credit. But online, you got to understand, I've got 4 classes with 140 students. I can't just give you that form of the test without giving everybody that form of the test. And there's just no practical way for y'all to send me the problems worked out just to use some round numbers. The tests usually aren't this long, but let's just say I have my test 1 is 10 pages long. It usually isn't, but just to make the numbers round. Okay, so I send you the test, it's spread over 10 pages. You write your answers out. You got no way to send it to me other than scan it in and mail it to me. Well, I got 34 people just in your class. So you're looking at 340 pages just for test 1. So I somehow have to get all 340 pages. I got no real way to write on them, scratch on them, and grade them like I usually do, except I print them all out, write and scratch on them, grade them. Well, how do I give them back to you? Well, now I got to rescan them back in with my corrections and grading and send all 340 back.
Yeah, it's tough. It's tough time.
Multiply
I can
that
feel
by,
that.
for just test 1 with 4 classes, multiply that by 4. Because I got 3 other classes, so you got 340 times 4.
Yeah,
That's
Professor.
1,360 pages just for test 1. And then there's 4 or 5 tests for every class plus the final. I would be here for the next 5 years, literally almost. I'm doing it that way. So this was the way I came up with last spring. You can see the problem worked out. The idea is, can you spot, is it correct, or can you spot my mistake where I screwed it up? And then you can put your answer in the form and you get your grade instantly. No, it isn't the greatest system, but I don't know, what else to do. Online, purely online. Online teaching D2L seems to be completely set up for English class, social studies, history, subjects, social science subjects, where you can literally put multiple choice questions in and true, false, etc. It's not really set up for your standard math class. Does that, I know the answer doesn't make you happy, but does it at least explain why we're doing what we're doing?
Yes, I'm kind of sorry for asking that dumb question.
Sorry for that long of an answer. Did anybody want to see any problems this morning? We are doing the test for last week over chapter 5, and we're also covering 7.1 and 7.2 this week. And there will be a quiz on 7.1 and 7.2.
A quiz on that this week?
Yeah,
Okay.
that's what we said in the instructions on Sunday.
Okay.
Standard quiz on 7.1 and 7.2, but also the test. That's why I'm giving the test out a day early by Thursday.
Okay. Thank you.
Yeah, I know it's a lot to load on you in 1 week, but I guess I should have given the test last week. It just got away from me.
Can we maybe go over one of the question quiz 2? I think I got different answer. Maybe you can explain it a little better.
Sure
quiz
thing.
2.
Let me set up the camera.
Mhm.
And if you want to feed me the quiz, because I don't have it in front of me, if you want to feed it to me when I set up the camera.
Okay.
Have you got it?
Let's go for quiz on number 6 first. I think that is true, but some reason is false.
Let me, okay, so this is quiz 2.
Yes.
Can you feed me the problem?
Is sine h over 3
Sine, was that H or X?
h and square root of 3? No, not square root. Yeah, sine h3. That's it.
H through, where's the 3? Under the H?
Next to h.
Okay, so I've got a sine H, but where do I stick the 3?
I think like sine h and then the value of
Value
x
of
would be
3.
3.
Okay, sine of H, the value of X equals 3.
Is page 380, 5A.
Okay, let me see if I can get it from that.
I think this is just one of the problems that you plug into the calculator, sine h of 3.
Yeah, but I put true,
Oh,
but
you
for
mean
some reason it's false.
cinch. I'm
Cinch.
getting it. You mean the cinch.
Sorry.
S-I-N-H. Cinch of 3. In other words, you're looking for cinch of 3.
Yes, cinch of 3.
Okay.
When I'm punching calculator, I got the right answer. It's 10.10787.
Right.
But on the quiz says false.
Well, let me look.
From what I remember is on the quiz, it was a decimal place was off. So
I think
instead of being 10.01, it was 10.1 or something.
Yeah,
Because I messed up that too.
I missed that too.
yeah, that's kind of tricks I did do, yeah, to throw some false answers in. I switched the digit, I think. Let's see if I can find it. The quick way is go to the catalog, punch S, and come down to cinch. There's a cinch 3. Yeah, the correct answer is 10.0179, say.
79?
I think on the answer on the quiz, I had 10.1079 maybe.
I got you. I didn't pay attention that detail.
Yeah.
0,
Sorry,
107.
it's tricky, I guess. Doggone,
Okay.
I should be ashamed of myself.
Yeah, I got that wrong the first time when
Okay.
I took my quiz. And the second one, I think I got wrong, is on quiz 2, page 370, problem 13.
Page 370, problem 13.
Yes. because I thought it's a tangent, not a log form.
Okay, let me look. So
But it's
that
true.
looks like integral of an e to the 2x
Mm-hmm.
over 4 plus e to the 4x dx.
Yes.
Did you want to see it worked out from scratch?
For my own answer, I got is 1/4 tangent -1 e to x divided 2. I got different answer for that one.
Okay.
It's maybe
Yeah.
because I mistake.
Yeah, see, this is where math doesn't really. In fact, I was trying to teach this class without even this camera set up. I had no way to put problems last spring. I hadn't worked out this camera setup. I had no way to show step-by-step problems last spring. I just did it from canned videos. Those poor people. The only way I can't just jump to an answer. This isn't English and social science where there's like however many steps to get there. Do you want to see them?
Let me start my screen. Let me show you the work I
Okay.
done. Okay. Can you see it?
No, I really can't doing it that way. It's just a blur. If you can
Yeah.
hit your share screen button, I can see it on my big screen and then I can do it. You know how to hit your share screen button?
Share screen. Let me see. If I don't think so, I can share my paperwork. I think we only can share the computer screen.
Yeah. Yeah, that was where, now that I think about it, that was working on,
How about can I take a picture and send to your email?
yeah, do it that way.
Yeah, I'm doing it right now.
Sure. See, I can handle one person doing that, but not all 4 classes. It would completely overwhelm things. So yeah, send me a picture of it because I can scratch and grade on it, hopefully show you where it's going wrong, and then take a picture and mail it back to you.
Yes, I just sent it.
Okay, sure thing. Well, yeah, one person's not a problem. All 4 classes is a big problem. Yeah. All right, I'll have to do that after the Zoom meeting.
Okay, I think that's it. That's all for me for the question I have today.
Okay, well, sure thing. Did anybody else want to see any other problems, or
Yeah,
did
can
you
we
want
maybe
to?
do some of this week's stuff?
Sure,
Like,
7.1 and 7.2.
yeah.
Okay.
Uh, let's do question number 17 on page or on 7.1.
Okay. 7.1. Okay. Page 450. Says f of x squared add 2x, g of x plus 2. Supposed to sketch the region, find the area. Let me just give a Reader's Digest version of what Chapter 7 is. Chapter 7 is all calculator work, and we're going to be calculating different things. In 7.1, we're finding area under curves. 7.2, we're finding volume. 7.1, just to give you just the generic thing, This is the generic curve that's going to work on about 90% of our problems here. Take an f of x between an a and a b, shade the area, and that area is the integral from a to b of the f of x dx. They should have covered that in Calc 1. Does this ring a bell?
Yeah, we did.
Okay. More generally, though, because a lot of areas do not go all the way to the x-axis, more generally, you have a top f of x and a bottom g of x. I'm sorry, shading this, g of x is on bottom, again between an a and a b. And your area, a to b of the f of x, that goes all the way down to the x-axis. I'm sorry, didn't want an equals. But you see, just f of x covers all of the g. So if you want to take out this area under g, you go minus integral a to b of the g of x dx. So you're taking away this area right here, leaving what's in the middle in between. This is perfectly valid, it's just a little long, so they shorten it by combining them. Here's our general formula, a to b, f of x minus g of x dx. I always use this form, and if I realize it's this situation, here basically the g is 0. And you throw it away, and you have just this form. Now, you cannot take these formulas too literally. You have to, they're just schemes by the logic. And the logic of this is that this is top minus bottom. The top of the curve minus the bottom of the curve. And that, in their homework, they do not feel obligated to always make the top F and the bottom G. Okay, it's just a generic scheme. In other words, when I go to 17, and I put, well, it's F minus G, and I just put F minus G, you may or may not get the right answer. Because I haven't graphed this, and I really don't know if this is the top or if this is the top. So that, to work on a specific problem, when they just give you the generic curves, you got to graph them and figure out which is the top curve formula and which is the bottom formula. All right, so let me go to the next page. Back to 17. F of x, x squared plus 2x. G of x is x plus 2. So step 1 is to sketch the graph. This is why we have graphing calculators. Hopefully everybody knows how to do two curves. Go to y equals. The order you enter the curves doesn't matter. X squared, add 2x, x plus 2. Usually I use a standard window. It's already set up, negative 10, 10, 1, negative 10, 10, 1. Go to graph. There's the parabola, and there is the line. Okay, I'm going to try to do my best to sketch this. It looks like you got a vertex on that parabola, like nearly over 1, down 1. Sometimes these start to become projects. Parabola does something like this, and it does go through the origin. And your line is crossing like -2 over, almost basically on that x-intercept, and then crossing up to here. All right, the area between these is going to be shaded in here. Okay. Hopefully you can see that what I warned you about is happening. This is actually the top. The line here is the top, and this is the bottom. So it actually should plug in G minus F. Top curve minus bottom curve. So yes, do not take the formulas F minus G too literally. So this is actually going to plug in integral. The top is x plus 2. The bottom is x squared plus 2x. But make sure you put that in parentheses. All right, any questions so far? We losing anybody? Can you see what we're missing?
The intersect points.
The A and the B. Yep. So that's the other thing. It's a little bit of algebra to figure out the A and the B. To find the A and B, I'll stick them up here. To find the A and the B, you set the curves equal. So we're going to set plus 2x equal to x plus 2. Because that's where the curves cross. So they have equal values at those intersection points. In effect, you're finding the intersection points. So I'm going minus x minus 2 minus x minus 2. That'd be a plus x and minus 2 equals 0, because your 2x minus x would leave a positive x, and you just have a minus 2. Hope y'all are good factors. Two numbers multiply to -2, add to 1. So it could be x plus 2, x minus 1. Your 2 minus 1 is 1, and 2 times -1 is your -2. Then x equals -2 and positive 1. So this would be at -2, and your positive 1 would be right there. So your area, integral from -2 to 1, x plus 2 minus x squared plus 2x dx. All of the integrals in this section are going to come with numbers. And we said the general rule was you see an integral with numbers, you just flat out just go straight to the calculator. Now, I'll warn you, the entries, particularly toward the back of the section, are going to get pretty darn complicated. There's going to be a lot of complicated calculator entries in this chapter. Now, if you want to simplify things and, distribute the minus, combine some terms, get a simpler entry, help yourself. Hope everybody knows I've got this darn old interface. I'm just going to punch it as is. Math 9, and you may be lucky enough to have the interface where it looks exactly like this. But if you remember the format you need the formula. So I need x plus 2, subtract parentheses, x squared plus 2x, close. All right, then I'm going to need a comma and x. So I've put in the formula, then an x, then the lower limit was -2, and the comma on the upper limit was 1. This old darn old interface, pretty cumbersome. I'm coming up with 4.5. Do you guys have that newer interface where it looks exactly like this?
Yeah, I do.
Yeah, that's nice. And again, you can simplify the middle, you know, as much as you want. That's helpful. I will be simplifying some of this because otherwise the entries are just get overwhelming toward the back of this chapter. I'm going to look this one up rather than spend the entire next page working it out by hand. This is 7-1.
Yeah. It was 9
Have
over.
to look.
Yeah, it was 9 over 2. That was the answer they gave.
They have 9 halves?
Yeah.
Okay, which is 4.5. Okay. All right, there's one other little scheme for this section. They will give you some formulas, functions of y. And that graph looks like this. This is an f of y and a g of y. And you're running between a c and a d. And that area would be an integral c to d vertically f of y minus g of y dy. And again, don't get too wedded to the exact letters. The logic is that this is the right side, right, minus left. That's so you can keep this positive. The right is bigger than the left here. And this keeps this integral positive, so you wind up with positive area. Anybody want to see an example of this one? I don't know if I actually got that far down to sign them. It'd be like 22. I'm sorry, 23. Anybody want an example of that?
Sure.
Okay, try 23. Your f of y is y squared. P of y is y plus 2. Okay, I have met people, x and y, it's all the same to them, so they'll just punch this in like it's an x and then cry when they realize they're not getting the right graph. Your calculator only graphs y is f of x. You understand why? It's because these are functions and they pass the vertical line test. Vertical line test. So you know how y is your f of x? Well, I've just written it. Y is f of x. Well, when you see an f of y, this is an x. So when I have x equals y squared, I do a square root. I need a plus and minus square root of x will equal square root of y squared. Plus or minus square root of x equals y. Y is plus or minus square root of x. Over here, x equals y plus 2. So x minus 2 equals y. Switch it around. Y is x minus 2. So we're going to graph. I'll write out what's on the calculator screen. Say y1 would be a square root of x. Y2 would be negative square root of x. And y3 is your x minus 2. To get a correct graph, for a correct graph. Y equals, I'll clear this off, square root of x, negative square root of x, x minus 2. See, it's a sideways parabola and there's a line cutting through it. Okay, so if I quick graph of that, getting a sideways parabola, which does not pass vertical line tests, so that's why you've got to bust it up like this so you have individual functions, so it's overlaying it. Square root of x by itself is a function, negative square root of x. This is the square root of x, negative square root of x, and your line is doing something like this. This would be the area. This is your right curve, and that would be your line, y plus 2. This is your left curve, and that would be your y squared. Same idea, we've got to find the intersection points. Intersection points. That's your C and D. Set the curves equal. I'll do that on the next page. Before I do, have we lost anybody about this? Any questions? Anybody want to ask anything? Okay, next page, we'll set those curves equal. Y squared equals y plus 2. Solve. Y squared minus y minus 2. It's almost a mirror image of the last problem, except you're getting y values. Y minus 2, y plus 1. Really similar. I think the signs are quite different. So I'm getting a y of 2 and y is negative 1. Just quickly resketch. You had the sideways parabola, cut the line like this. So up here you're at y is 2. Here you're at y is negative 1. So when I set up the area, it's going to run from negative 1 to 2. Your right curve was the line, so that's y plus 2. Your left curve is y squared, dy. Okay, now here's one other thing people don't realize. The answer is a number. The actual letter you use is immaterial. I could punch this in Y if I wanted to, but every time I hit a Y, I got to find alpha Y on the keyboard somewhere. I find that a kind of a real royal pain in the you-know-what. So when I actually punch in, I actually use X. And just your standard X key that you're used to. It's easy to find because the exact letter you use doesn't matter. So I'm actually going to punch in and use X. So Math 9. I've got X plus 2 minus X squared, comma X, comma negative 1, comma 2. Close. Because the answer you're going to get is a number. Ah, it happens to be 4.5 again. Let me, should I double check that just to make sure I didn't screw something up? Anybody have the answers in front of them? 7, 1.
I can get it.
Okay. This was 23, 7, 1, 23.
Yeah, it was nine halves.
9 halves again. Got the same answer on this one. Yeah. I'll show you. Yeah, the book gives you that curve just to show you if anybody. Book gives you, here it is right here. Gives you the curve and then gave you a decimal. I guess they wanted you to work out by hand and get the fraction, but you don't have to do that. Do you want an introduction to 7-2?
Yeah.
Okay. Yeah, this is where things start to get technical. 7.2, just very quick show of formulas. It's about finding volumes of revolution. You start the same curve. Your f of x between an A and a B, but we're going to revolve it around the x-axis. And that's going to mirror it, if I can mirror it, down here. This is its mirror. And we are going to find the volume. When revolved around the x-axis. You can see pictures of the book doing this. This comes up in machine parts and engineering. The one on the first one and third one show a horizontal axis you can take to be the x-axis. And we're also actually going to do stuff around the y-axis. That would be this, a bottle and a piston. And I know you're dying to know the volume of these kinds of surfaces and parts. I'm dying to tell you. I'll use this cup. I don't have a bottle in front of me. You can imagine an x-axis, and my screen froze. Okay, here we are. Imagine a horizontal axis going through this, and this top surface, the top edge, being your f of x. And if it's spun around that center axis going right through this, you create the volume. You can do this with water bottles, Coke bottles, beer cans, whatever you want. And you can calculate the volume enclosed. See, in a cup, I can fill it with water, drink it. It has a volume. Okay, we're going to do this with a lot of, this is where things get really technical for a lot of different situations. This is the first very basic one. All right. I'm going to derive the first one, and hopefully you'll believe most of the rest of them. Looking in this, I hope you see circles. All right, any spot I did, you see a circle. But the problem is they're not all the same size. They vary in size because their radius is varying. That's the radius. Varies. So you're using area. You're starting with area, and the area of a circle, hopefully you remember, is pi r squared. But your r is your radius, and it's equal to f of x. F of x is your vertical distance, is your y. Y is f of x is your vertical distance up. And it changes. Smaller over here, bigger over here. So it's given by whatever that f of x is. So area here is pi f of x squared. All right, well, how do we get to volume? Volume is in 3D, area is only 2D. Well, if I take two close together, I can separate them by a dx. So my volume is equal to pi. They generally start with a delta x, pi f of x squared delta x. You can call this the ith volume of a piece. when you sum up, there was something called Riemann sums from Calc 1, wave our hands. Bottom line, the formula, pi integral from the a to b, f of x squared, and the delta x between the two comes your dx. That's an f of x squared. Same idea from last section. It's more general. If your curve has a top f of x and a bottom g of x between a and b. So your volume then would be pi a to b of your f of x squared. Subtract off, because that goes all the way down to the x-axis, pi integral a to b of your g of x dx. Crush them together, put together. Pi a to b of the difference of f of x squared minus g of x squared dx. I use this one. They just, if you want to see the names used in the book, this one right here is called DIS method. Because when you revolve, in effect, you get a solid. They call this washer method. If you're familiar with washer that you'd put on a bolt, a washer has a hole out of the center because this inside, see this mirror is down here and you're hollow, like a washer. I always use this. And if I realize that the curve goes to the x-axis, in effect, this is 0, and it reduces back to DIS method. One other thing, notice dx integral, you're around the x-axis. Enjoy a simple universe while it lasts, because next week we hit section 7.3 and it won't work like this. But right now, dx integral, you're around the x-axis. Just really quick, or try to get to some problems because we're 45 minutes. You can do the same idea with the f of y, and they will. G of y, you're revolving around the y-axis. It will mirror over here. You run it between a C and a D, and your volume, pi integral C to D, f of y minus g of y dy around the y-axis. Same logic, right minus left. And I guess I should have written that on the other one. Top minus bottom. Don't get too wedded to exactly what the F is and exactly what the G is. I treat all these problems, actually once you get into it, it probably looks very complicated. I regret that. It's really very simple plug and chug kind of problems if you know your formulas. So the two formulas you should know are this and this. Quick examples. Page 461. I guess I'll charge into the first one. This is 7.2, problem 5. They actually give you the graph. It's the square root of x between 1 and 4. 1 and 4. Find volume around the x-axis. I'll show you it out of the book. Right here. They give you the graph. they give you the graphs through 11, and then over here, they don't. You'll have to graph them. But also, they're changing you around the lines, and that's going to put hair on your chest. Maybe I'll get a quick example into that. You have to change things. Actually, maybe not. Maybe I'm going too much. This might be too much since we already done 7-1. May not get to that today. May have to wait on that until Friday. All right, but basically, I'm going to plug and chug. Pi, I'm going to write the full formula down. A to B, f of x minus g of x dx. This would be your f of x. Your g of x is 0. So I'm throwing this piece away. Just go pi 1 to 4, square root of x for the f of x, but it's squared dx. If you want to plug and chug right on this, fine. You can also realize square root of x squared is just an x of an x dx. And you can plug and chug and pop out with your answer. That's a lot to throw at you, almost 50 minutes in one session. Maybe that's enough to get you going, and by Friday we can show you other lines. It's a lot to throw at you all in one session. Anybody want to see any other problems worked or have any other questions before we end? Don't make these. Go ahead.
Could you, like, you don't need to work out a problem, but could you kind of just explain what to do for like 13, 14, or 13, 15, like where they just give you like y equals 2x squared and then y equals 0 and then x equals 2?
Yeah, you got to graph them. You want to see 13 first or another one like 15?
Yeah, 13 is fine. Yeah.
All right. Well, 13 is going to be really similar to number 5. It's the same curve. Y is square root of x, y is 0, and x equals 3. Find volume about the x-axis. A is the x-axis. Maybe I'll contrast A and B, and we'll save other lines for Friday, because other lines gets pretty technical. So A, find volume around x-axis. Okay, you need a curve. We just did the square root of x, but I'll go ahead and draw it for you again. Actually didn't draw it on the first one, but number 5 was, they showed you square root of x, but when you graph it on the calculator, square root of x, you're going to get it from the origin up. So it's a sideways, in fact, this sideways parabola, but the top half. Y equals 0 is the x-axis. X equals 0 is the y-axis. So they're going to the x-axis. And x equals 3, you can't graph on the calculator. I hope you recognize that's a vertical line. X equals numbers are vertical lines, y equals numbers are horizontal lines. So 1, 2, 3, there's your x equal 3. You can't show that on the calculator. Calculator only graphs y equals, that's it, not x equals. So there's a vertical line you can't show on the calculator. So you're going around the x-axis. Volume, then I'll write out the full formula. So you know what you're plugging and chugging into. F of x minus g of x. It's really similar to number 5. with the upper limit of 3. So you're going from 0 to 3, in effect 0 to 3, with a g still of 0. 0 to 3 of square root of x, and it's squared dx, and you can punch away. All right, let me contrast it with b. b is around y-axis. Well, that formula is going to be C to D. They use different letters to remind. This A and B, they're taken to be X numbers. These limits are the same value of the letter as this is. So with the DX, these are X values to keep the same logic and everything consistent. Right, X equals. Here, it's Y equals because minus G of Y dy, because you've got a y integral to go around the y-axis right now. So we've got to convert y equals square root of x. In other words, solve for y. I'm sorry, solve for x. Y squared equals x. So that is your left curve. I want to redraw it down here. That's this curve. Your vertical line, this is your right. This is your left. So it's right minus left. Integral, the right would just be 3. Minus your left is y squared. dy. In Calc 2, we are completely in a universe where you've got to use the same letters in your formulas as you have here. So if this is dx, these are in x. This is in y, these are in y. Or numbers. You'll have numbers. Numbers or this letter. That won't be true in Calc 3. Calc 3, you'll be mixing letters all over the place. Coming attractions. Okay, the C and the D. Now you see, it's not 0 and 3. Those are X numbers. At least, but actually it is going to be 0 because you're going through the origin. So your Y value here is also 0, but it's not the same X0. It's Y0. Y is 0 here as well. So that's 0. But you're not 3. That's an X value. Up here, you're at 3 for x, and y is square root of x. So y is the square root of 3. You're going to go from 0 to the square root of 3. That's your y value. 3 minus y squared dy, and again, you can punch it in x. All right, I know this is really fast. We've been at this a lot, throwing a lot at you. Was that as clear as Lake Lanier?
Yeah, that definitely helped.
Okay. You will not get the same number. You're not supposed to get the same number. They'd have to really cook it to get the same number. You know, you wouldn't necessarily get the same number sending this around the, because you got a completely different shape. Up here, you're mirroring down here. Over here, you're mirroring like this around the y-axis. It's a completely different shape. So you're not going to, the point is not to get the same number. You're going to get different numbers. C and D change the lines, and that's a completely different animal, and maybe we've thrown too much at you. We should let you try to mess with this, and we'll throw that at you on Friday.
Okie dokie. Thank you.
Okay, anybody else want to see anything or ask anything before we end the meeting? All right, hearing nothing, we'll end the meeting and be back at 9 o'clock on Friday for another Zoom meeting. Feel free to email me with any questions you have between now and then, and we'll go ahead and end the meeting. Appreciate you coming out early on a Tuesday morning. Thank you. Oh, Mr. Quintero.
Hello.
Yes, I don't see anybody else on the meeting. I guess this is about our only way to talk to each other. Are you comfortable doing this? Because I'm not supposed to discuss your personal situation in front of anybody. Do you give me your permission to do this, or would you rather do it purely by email?
No, it's okay right now. We're the only two in here.
Yeah, it seems like we are. So, okay. Yeah, I have removed you from the role because I did not get a syllabus quiz grade for you.
I think it must have been like a really silly mistake because when, like the first week that we had to do it, I went class by class in a row, like doing all the quizzes, and I could have sworn I double checked everything and made sure I did them all. Is there any way I could be added back or no?
Yeah, if I get a response from you, but don't mess with the Google form now.
Okay.
If you can find the syllabus quiz, just send me an email that says number 1 T for true, number 2 F for false, or whatever you think the answers are.
Okay.
Just send that in an email, 1 to 10, 1 true, 2 false, 3 true, all the way down to number 10.
Does it have to be correct or because I don't have the
No,
quiz?
well, yeah, whatever you think the correct answers are.
Because I can't see the quiz anymore since I'm not in the class.
Rats. Okay. I will
Or maybe hold on. Maybe I can see from another class.
well, I'll tell you what, I will email you the quiz. I'll make a note to do that.
I got it. That's 10 questions, right?
Yeah, it's 10 questions, says syllabus quiz.
Yeah, I can do it for another class and I'll just email you the answers.
Yeah, but that's not the same syllabus quiz, is it?
I think they all seemed very similar or the same to me.
Well, okay, you're looking at the one straight from D2L. That may be where you answered.
Yeah.
I wanted the one that was in the left column of D2L that was specific to my class.
Oh, okay, I'm sorry. Yeah, I probably missed that one.
Yeah, okay. Let me email that to you. Just answer your responses, like I said, whatever you think they are,
Yes, sir.
true, false. 1, true or false, 2, true, false. You got the idea? Just type it out in an email.
Yeah.
Okay.
Yeah.
Send it to me. I will send an email to the registrar and have you added back to the class.
Thank you so much. Sorry about that.
Okay, no problem at all. And yeah, I'll add you back in.
All right, I'll do it as soon as I get it.
Sure.
All right, thanks.
All right, very good.
All right, have a good
Okay.
one. Bye.
Same to you.